This is the data store management best practices. My name is Mark Carlson. I'm a system architect here at Esri with the business development. And here with me is Lawrence Clinton. And we will be reviewing some of our best practices for data management. We'll be covering, there we go, a brief overview of what does the architecture look like, what apps become available once you do register these different types of data stores to the environment. I'll also cover some of the tips and tricks on installation, configuration, what to look for, and then we'll dive into backing up the data store, restoring that, and in some cases, some customers need to move that data store to a new machine. What does that look like? What all does that entail? And then get in some demos, and then upgrading, and then any questions we can take at the end. So what we have here is this is our typical ArcGIS-based enterprise deployment. Hopefully you've seen this quite a few times. It has our web adapters, portal, ArcGIS server, and our data stores. And typically in these diagrams we show the relational and the tile cache. But also to expand the capabilities of our enterprise, we can now include the spatial temporal data store. This has also been called the big data store, and we'll kind of go over its function and what all you get with the spatial temporal. So how many of you guys have actually installed one of these data store types? Oh wow, great. And then how many of you have used the spatial temporal data store? Okay, good. So we're going to kind of review the functions that are exposed with each one of these as we register, and then what capabilities you get out of it. So initially when we register the relational data store, this is what creates our base enterprise deployment. This actually allows us then to publish hosted features, and then allows the capabilities of Survey 123, Insights, Workforce, and the GeoPlanner app. So what do we get when we register the tile cache? The tile cache allows us to store 3D data, which then allows us to produce scene layers, which then can be viewed via the Scene Viewer app within our environment. So the spatial temporal data store actually opens up a lot of capabilities for the ArcGIS Enterprise Stack. Not only does it allow us now to use the new app at 10.7 Tracker for ArcGIS, but it also is a repository for the archive information coming from GeoEvent. So now GeoEvent writes to the spatial temporal data store. And then the GeoAnalytics server uses this as well, to where it actually, when it is done with its processes, this is where it stores that information, is the output, is the spatial temporal. And along with the GeoAnalytics server, we now have those tools that become available in our apps, such as ArcGIS Pro and the map viewer within our portal. All those analysis tools become available and ready to go just by registering the spatial temporal. So for the installation configuration, you can use an OS or a domain account to install the software. And the minimum requirements that we see here are actually minimum requirements. So we say 13 gigabytes of RAM or 13 gigabytes of disk space is minimum, but that's just for installation configuration. You really need to look at what data you want to store in these databases to really, expand your resources on the machine itself. The memory that we have included here, is the 8 gigabytes of RAM for both the relational and tile cache. Now that is if it's on its own machine. So that's just kind of important. If you're going to have both of them on the same machine, take that into account as well. And you'll want to make sure you're monitoring these data stores to make sure that you have enough resources on the box, because you always expand it as necessary. Now the spatial temporal big data store its minimum is 16 gigabytes of RAM. Now, it's highly recommended that the spatial temporal is installed on its own machine, because right off the bat, it's going to consume 50% of those resources. So it's going to compete for whatever application that you have on there if you decide to install it the same application on there. Another kind of consideration is to look at those thresholds. We have default thresholds, and what this does is that it actually maintains the data within the data store. So it's not going to let you, populate that data store with information that, once you get to a certain point, it's going to stop writing data because you ran out of room. So it's actually going to retain that, it's going to stop. You're going to see some, possibly some error logs that come through that says, hey, it's going to go in read-only mode, and that's to protect you and your data so that then you can go in and expand those resources on that machine as well. Some other key points to look at are the ports that each one of these data stores use. Make sure these ports are open to your ArcGIS Enterprise and each one of these data stores appropriately. The relational using that 9876, the tile cache is 29080, 29081, and then the spatial temporal is 9220 and 9320. All of this is documented that we have that's posted. So just make sure when you're configuring your systems that you're allowing these ports to be open in communication between the server. We do offer a couple of different ways that you can configure it. So once you have it installed, you need to have this configured now with your ArcGIS Enterprise deployment. Notice here that it's port 2443 is how you access the configuration wizard. And this is going to be an interface that you can use in order to configure this. If you're not on the machine itself where the software, the data store is on, you can use this interface to configure it. Simply just give it the GIS server URL. So this is your hosting server. And then specify the content directory for your data store and what data store that you're going to apply this to. Like I said, you can have the relational and tile cache on the same machine if the resources, if you're accounted for that, that is possible. And if you only register the relational data store and not the tile cache, but you've decided that, hey, I want to register a tile cache data store on that same box, you can always go back and do that as well. So just know that you can always go back and add an additional data store to your site. Now, we will provide you with a warning if you do try to select the spatial temporal data store on the same machine as the relational or the tile cache. So it's just highly recommended not to do this. Another way is through the command line utility. When I'm setting up all of our infrastructure, I like doing it this way. So I just log into the machine, either SSH or RDP into the machine that I have the data store installed, and I run these commands in order to configure my data store. I also kind of emphasize the configuring of the backups. You want to make sure that this is set to your requirements, the location where you want your data stores to be backed up to. That way, if anything does happen, you know where your data store backups are, and that you can always retrieve those at a later date. And I've kind of given you some of the links, the enterprise.arcgis.com. We do have the Windows and the Linux command lines that you can reference. I use the describe data store quite a bit. I manage a lot of the environments, like I said, for Esri. I'll come into here, just do a quick describe. For instance, this is the spatial temporal data store. This way I can say, okay, what is my threshold? How much free disk space do I have on it? Making sure that it's running properly. Where are my backups? And in this instance here, I have a backup location in my S3 bucket in Amazon, but I have yet to configure the backup schedule. So I want to make sure that's configured as well within that configuration. And it shows me all the machines that are within my cluster and that have been registered appropriately with this data store. Another example, this is actually on my hosting server. I have my relational and my tile cache, and again, I'm just kind of viewing to see, is my backup on a schedule? Like you can see here, it's scheduled every 4 days, which is the default for the relational data store. And, is it started, is it healthy? And just some more information about what is actually installed on that one machine. Another instance where if we want to have a multi-node data store, this is to say that if one data store goes down, I want to make sure that I have a standby data store ready to go and that it'll transfer over. So how do we do that? So we will first, install and configure the data store on the primary. And then we want to install that on our standby machine, but we got to verify that, again, all those ports are available to that standby machine. We then want to make sure we use the same user to install the standby. So if I used, ArcGIS user to install my primary, I want to use that same user on my standby. And then that way the replication can start and just validate that the standby machine can see the same network file share for the backups, and you're good to go. In the event that the primary does become unavailable, what happens, obviously the replication would discontinue, and then that secondary machine automatically becomes my primary. And with this, then I can go in and see what has happened and restore, a secondary machine on this as well. This is kind of a sample ArcGIS enterprise deployment. But, we have some of these running up in the cloud today, where we would have registered our data stores appropriately to our hosting server. To where our tile cache and relational data stores are backed up to some network file share. We have a spatial temporal data store cluster that I'm actually backing up to an S3 bucket. And then I federate my geoanalytics and my geoevent servers to my environment so I can leverage those data stores and provide this to all of the solution engineers that have these demos and stuff. So. And with that, I'll hand it over to Lawrence.
Okay, so Mark covered the configuration portion of the presentation. I'm going to go into the backing up of the data store. So once you've configured your ArcGIS data store, you're going to want to implement a good backup policy. And so backups by their nature can grow rather large. So a good policy is to actually configure that backup location to a network share. This has several advantages. One, the disk space on the machine that you configured the data store is not going to get used up. And then two, if something happens with a data store machine, you have a way of restoring it. You just have to go to your network share and restore on a different machine. And so the way we do that is to use the configure backup location command line utility, which is located in the tools directory. And for the relational tile cache data store, what you would use when you run that command is operation change. So for the relational tile cache, there's already a default backup location when you configure the data store. So operation change will change it to the new network share. For the spatial temporal big data store, we don't have a backup automatically configured for you when you configure that data store type. So you have to use operation register. So use that in combination with the location and the store type, and you can configure your new backup location. And then once you have it configured to actually generate the backups, you have to run the backup data store command. And it takes the backup name as well as the store parameter, whether it be relational, tile cache, or spatial temporal. Now, starting from 10.6.1, for relational and spatial temporal, we actually support, as Mark referenced, the ability to configure to multiple file-based locations. So your default location will be file-based. It'll be that network share that you configured with plenty of disk space. But if you publish data and you have a very important configuration and you want that extra backup, you can configure to another share. Configure another backup location to another share, or to S3, or to Azure Blob Store. Just gives it that extra safety net. So with a relational data store, it automatically has a backup schedule and retain days set for you when you configure. So automatically, every 4 days, you're going to get a backup generated. And then it's going to keep that backup for 7 days. It's going to persist it. And it's going to repeat the process. For tile cache and spatial temporal, we don't have that automatically configured, but you can configure it. And the way to configure that is after you have those two data store types configured, run the update backup schedule and set your store type and the frequency, or how often you want that backup to take place. So with the relational data store, we have this option of point-in-time recovery, which is a great feature if you need to restore your data store to a specific date and time. Conversely, the negative side is if you look in the backup directory for the relational data store, you'll see all these wall archives, and it can consume a lot of disk space. So if you're concerned about disk space, and you're not needing to make a restore on a specific date and time, but rather just on a backup name, then you can consider toggling that off. And in fact, at 10.5.1, it's disabled by default, unless you did an upgrade from our early version, and in which case we persisted that property. But you can change it anytime you want. And the way you change it is by running the change DB properties command. And you either enable or disable the PITR. Now with this command, don't forget to pass in the -- store parameter for relational, or else you'll get an error. So once you have a set of backups that are reliable, you may come to a point in time where you need to restore your data store. Now, we have two basic types of restores, what we call internally in place and then out of place. So say you want to restore your data to 2 days ago from a backup because for whatever reason editing took place on a feature class and you're no longer wanting that, you want to restore it back. That's what we call in place. There's nothing wrong with the data store itself, but you're just going to do restore. And so you would just run this restore data store command, and you pass in the required properties. However, if your machine goes down, the data store machine goes down, and you're a wise administrator and put the backups on a network share, and you have access to them, then you can actually restore your data, get it back to a functional state, feature services will work, everything will be great, to another machine. And in that case, we call that an outplace restore. When you do an outplace restore, move the backups to the new machine, and then don't configure. Rather, run this command, restore data store, right out of the bat. And there's some interesting things you need to note here. So the -store parameter, you would just choose a particular type, for example, say relational. For your target, it's going to be the name of that backup, the name that you chose. Now the source location is actually the parent folder of where those backups reside. So if you look into the structure of the ArcGIS data store, the content directory, so C, ArcGIS data store, go into backups, you'll see parent folders like relational, cache, spatial, temporal. It's wanting that to that level of directory. Don't go deeper, just give it that. And then you have, that's for the source location. For bound just means I'm either going to register the server or not register the server. In almost all cases, you're going to want to register a server. So this property by default is true. You don't even have to specify. But if you want to test your backups, before you register your server, you can specify false to make sure it restores correctly. That's why the option's there. And then the data dir is just the content dir, see ArcGIS data store. Then you'll provide the server URL, server admin, password, and then this load data is actually specific for the spatial temporal data store. So for the spatial temporal big data store, imagine you can have terabytes of data, spread across, and your data is dispersed across several different machines. The data is actually sharded. When you have a backup there and you want to restore it, a lot of times you're just restoring to a single machine and you haven't thought about spinning up all the other machines in order to load all that data in there. So, with the spatial temporal data store, you can use this load data option and put false. In other words, you're just going to load the schema up. Then you spin up or configure all your other spatial temporal big data store machines, assuming you lost all of them. And then you run it again with load data true. Then it will load the data. It's a quick, fairly efficient way of getting your spatial temporal big data store back. Now, there are times when you need to move the data store to a new machine. We cover one option. That's the outplace restore. But running that command and adding all those properties, it takes a toll on your fingers. There's actually a simple way of doing this. So you have one machine, and you know you're going to retire machine A, but machine B is the new server 19 that you want to install the data store on. What you do is you install the software on the new machine, configure it as a standby, then go to server admin, and there's under the machine's REST endpoint, you can change the role. In other words, the new standby becomes the primary. Then just remove this. There's an operation to remove that machine. So now you just transferred everything over. Once it's configured, all the data store pushed over to the new machine there, retire that machine, you're good to go. So it's a quick, efficient, simple way of moving your data store to a different server. Okay, so in this demo here, I'm going to show how to do administrative functions using Python and Jupyter Notebook, the ArcGIS data store. So in this demo, we're actually going to use the ArcGIS Python API for, say, publishing. Then we're going to use standard Python libraries for running the ArcGIS data store tools. So because we're going to use this ArcGIS Python API, there's a way you should really open up your notebook so you can have access to those libraries. So install Pro, and then you use CD to C program files, ArcGIS Pro bin Python envs ArcGIS Pro -py3, and then run Python exe-m notebook. And then once you have that, this will open up, it'll show a token, copy that token into your browser, and then voila, you'll have what we have here. All right, so first off, you want to import all your libraries, all the ones you're going to use. In this case, we're probably going to use mostly subprocess module and then the ArcGIS API libraries. So we're going to reference it here. So the way to run this cell in Jupyter Notebooks is just Control Enter, and it should import all that information in there. So on the second portion, we're actually going to publish some data. In this case, we're going to publish a scene service and as well as a hosted feature service. So just to show you, I'm going to go to this portal here. We don't have any data in here. We have that sample world cities that comes when you federate. You'll see it there. But we don't have any data. So we're going to initiate this, then I'll explain the code that we use from the API. So we'll come here, Control Enter, and we'll let that run a little bit. Now, within each of these cells, I have the main statement. When you do your own Python scripting, you're probably going to have one. You're going to have one definition or create a class, and that class is going to call all your functions that you created below or your definitions. But here, we're doing a demo, so I have the main repeated several times. But within here, you'll see that I have the server credentials, the server URL, portal fully qualified name, content, all that good stuff. And I'm calling it or passing that information into this published data definition. So if you come up into here, that's where this guy is. And this published data definition, all it's doing is I am looping through this directory that I passed it, which is where my data resides. And I am joining in that path with the actual data that it finds. So it's a for loop. And then it sets all that information, the join information and the data it finds to this data variable. And then I also formulate my portal URL. So from that main statement, I also pass in the web adapter and the actual physical machine name. Now I have my portal URL. I pass all of that information into this publish FS definition. And here I use that library. What's great about this library, it's very quick and easy to get to portal, and it's really quick to add content and publish. So here I'm just passing here the portal URL, user, and password, and it will connect to portal. Once I have that connection, I then add my data that was parsed to it from here. Give it a little bit of time sleep of 10 seconds, and then I publish the data. And then, of course, I'll log the results using this this log definition, which just merely opens up a text file and writes it and puts a line return. And so if we go down here, looks like it published the Parks feature service. And then it is looking at or evaluating this SF3 SPK, which is my scene layer. So since Parks is up and going, so we'll go over here, we'll refresh this guy, and we'll take a look at the data. And you'll see this, if you use Notebook, good way to know if it's still moving is if you see that hourglass spinning. Okay, so it looks like this is in process, but this one should be ready. So let's take a quick look. All right, and this data item gives us a quick look into the columns. What's also great about it is it tells you how many features you have in here. It's quite useful. And we can go to the visualization tab to make sure our geometry shows up just right. And it looks like our geometry is drawing. Excellent. Now I just noticed that the demo finished. Let's see if it showed successful. Yes. So we'll take a look at the scene service now. So here's our hosted scene layer. We'll click on that. Open up the scene viewer. I should see a globe, and then it should zoom into the geographic area. Okay, and looks like that published successfully as well. All right, we'll just tilt it, just get a slightly better view. All right, great. So we needed that data because we're doing backup and restore, and there's no sense of backing or restoring anything if it's empty. So the next thing we're going to do is do the backup. So similar to above, I have under the main, the parameters I'm going to pass in. In this case, I have both a relational and a tile cache, so I just have a Python dictionary, which I have key value pairs with the name of the backup for relational, the relational type, name of the backup for tile cache type. And so I use a for loop, and I use variable names to represent. BK name represents either the relational or tile cache backup, store type either the relational or tile cache data store type. And I'm going to iterate this Python dictionary using conf.items. And I pass all that into the backup data store definition. So if we go up to, I'll go ahead and initiate first, and then we'll look. Okay, while that's iterating, we'll just take a look at this. Now, in the above example, we used an API, the ArcGIS Python API. In this one, we're going to use standard Python libraries. So here, you just change directly to the installer. The installer is the tools directory that contains all your data store administrative commands. So we change directory there. And then all we're going to do is emulate what the required parameters are from the command line utilities, which in this case is we're doing the backup data stores. We're passing the backup name and the store type. And then we're going to pass this to the subprocess module. And then from there, we're either going to get an output or return of 0, which means it was successful, and we'll log the result, or we're going to show it as failure, which is most likely a 1. And at this point, we have a relational data store backup that completed successfully, and we'll just have to wait for the tile cache. So if you go here, under backups. So in the prior slides, we talked about the source location and the level of depth you need when you're doing an outplace restore. This is what I'm referencing here, or it's relational and tile cache. Just point to that. Don't go any deeper. And if we go to DB backups, we see that we do have a rel 4. That's what we named it. And it looks like the tile cache also completed, so we should see something similar. If we go back up to tile cache, we should see our 4 in there as well. Tile 1, 2, 3, and 4. Okay, so that is complete. And then we just need to do the restore. So this is going to be very similar to the above example. Pass the parameters into your restore definition. We use a Python dictionary to iterate through the different data store types. We emulate what the restore data store command requires, all these parameters here. This goes out a little bit further. And then we pass it into the subprocess module, and we either get, again, return of 0 or a 1. And then we log the results. So we will do a control enter. And we'll do the restore. Now this is what we call in-place restore. The data store was fine, there was nothing wrong with it, but we're just restoring from the backup because maybe data got corrupted the next day or something. And so what we'll need to do or test is take a look at those feature services after this restore takes place. And if the data draws and the count's right, then the restore is successful. And so while that is running, this is the tools directory for the install. If you just type dir, you can see all the utilities they have at your disposal. There's quite a few of them. And the one Mark tried to emphasize to you is the describe data store. This you'll use over and over throughout the life of the data store. When you configure it, describe is going to tell you whether it was successful or not. It's going to tell you general information, how much disk space you have available, when it goes to read-only mode, tell you the actual version or release. So after you upgrade, you always want to check this. Are you at the new release? You can tell here that these are the data store types that are configured. You have relational here, and you have tile cache. And then it also tells you what your backup schedule is and how often it's being taken. In this case, it's still the default every 4 days, and I'm retaining them for 7 days. And then if you have multiple machines or a HA site, then you'll see all those machines listed under the member machines here. So it's a good way to come back to your data store, check on the status, make sure everything is good. And notice that there's the relational, and tile cache is quite not ready. That's because it's being restored. And we're going to run that one more time once it finishes. So here, relational's done. We have to wait on tile cache. And while that's going, what we could do is take a look at, it just finished. Let's take a look at the feature service. Make sure the counts are still correct. All right, we'll take a look at the data. Okay, looks like we still have the right amount of counts, and visualization, we'll check on the geometry. And that looks like that's drawing, so that's good. Now, finally, we'll look at that tile cache. We'll run describe again here. And based on the status here, it looks like the tile cache is back up. We'll open in Scene Viewer. And we'll make sure that we can still see our buildings. And looks like it's all there. Okay, and then if you want to repurpose the script for your own needs, you can see me afterwards and give me your business card and I can send it to you. Just put maybe Python or something on the card. So that's the demo portion. So now we'll go into upgrades. So before you upgrade your data store, there's a few procedures you want to do to ensure that you can get back to the previous state or you can redo the upgrade. One of which is to stop the service and actually make a copy of that content directory, the ArcGIS data store, and put it in a safe location. So you can always repurpose that or bring it back and redo the upgrade, or you can use that, uninstall the binaries, the new software, put the old ones on, you can hook it back up. Then you want to be able to generate a backup, or if you're at 10.4.1 or earlier, an export. And then you want to make sure that your ArcGIS data store account has permissions on the content directory, the install directory, before you do your upgrade. And then as a matter of order, always make sure you upgrade the server before you upgrade the ArcGIS data store. That's required. And on the new upgrade procedure, things are a bit simpler. You just install the new software on all the different machines, and then choose a machine, open up the ArcGIS data store wizard, and then the rest of the machines will automatically be upgraded for you. So you don't have to upgrade one then the other, but rather it figures it out for you and upgrades it for you. So you install the software first in all the machines, and then proceed to the upgrade portion, or the configuration portion. So for example, you start with this wizard here, and if you notice, the syntax may be hard to read, but basically it tells you to make sure you have all the software installed on there before you proceed. And it tells you that if you didn't make a backup or copy, please do so now. So it kind of gives you a prompt or warning beforehand. Assuming you did all that, you provide the server URL and the username and password. It will do a prerequisite check. Checks to see if you put the software on all the new machines. Checks that it can access server. And checks the version of ArcGIS data store itself. Once all of that passes, then it will proceed. And you'll see this when you're upgrading, just to give you some indication of how much is upgraded at any point in time. For the spatial temporal big data store, you could be dealing with terabytes of data that could take some length of time. So we put that indication in there so that you know that it's processing, but you also have an idea of how far it is in the process. Once it completes, you should get this upgrade status, and it should tell you the machines that were successful. And then finally, you'll end up with something that looks like this configuration status page. Now, after you upgrade, again, run the describe data store command. It'll tell you, if all the data stores that you upgrade are up and running. As you notice, during the restore process for tile cache, it showed an error on the tile cache portion. So it's a good way to look at and see the state of your ArcGIS data store. And then finally, you can go to server admin or server manager and do a validation on your data store. Make sure servers can still talk to it. And then, as we did, verify that your services still work. Okay, and then Mark and I are open for questions. And if you have anything specific to your configuration, you can come see us up here as well. I think the guy in the black shirt was the first guy. You and then you.
All right. So I'm new to enterprise.
Okay.
I actually have two questions. Number one, I'm new to enterprise. Can you talk into the benefits of configuring the data store here rather than just using my own Postgres and RDS or something like that? And secondly, can you speak into the technologies that are running underneath the hood, both the spatiotemporal and the relational data?
Sure. So if you're running a standard enterprise geodatabase, and you have that registered with your ArcGIS server and you're publishing services to it, what you'll notice is that you'll have an ArcGIS sock that gets spun up on your server side. And if you publish multiple services, those socks accumulate and your memory resources run out. With the ArcGIS data store, you'll see a small Java process. You won't see any socks get spun up. So whereas with the standard implementation in years past, you might have a limitation of, say, 200 or so services you can publish. With the ArcGIS data store, you can publish 10,000 services. Moreover, instead of having a database manager or a DBA, right, manage your SQL Server or Oracle and take backups for you, data store does it for you. So you get those advantages. And there's a lot of flexibility. You can restore across releases as well. With regards to the underlying technology, we don't put great strides into hiding what it is, you can figure it out. But at the same time, we build out our applications around it. So it's not your run-of-the-mill, out-of-the-box enterprise database, but rather it's now applications built on top of it to make it work in a very specific manner. So exposing that information could just lead to problems and lots of tech support incidents.
Thank you.
Sure. I'm sorry. You were.
Yeah. So say one of my users accidentally deleted one of the hosted feature services and goes to your desk and says, "Can you restore specifically that item for me?" What are your options to do so?
So we don't have a specific. You won't be able to restore a specific feature service, but you can restore to. You can do date and time or a particular backup to put it to a prior state that you could do.
Changed after the backup, right?
Yeah, you would actually. Yes, sir.
On a few occasions, we've had the case when the license expired, then we had to relicense port the server, and then we also had to deal with the data store. Can you speak about licensing and data store in those situations?
Yep, sure. So we have, there's a, oh, absolutely. I sure can. That's a good idea. So the question was, in certain situations, the license can expire on portal and server, and how do you deal with that with regards to the ArcGIS data store? So data store gets its license from server. So when you update the server license, there's actually a command line utility called update license that will pull that information to the ArcGIS data store. So just run that. Anytime you update server, run that command.
Are there any
Yes, sir.
management tools for actually managing the data in data store, like growth, storage, things like that? We have a storage guy that wants to know how fast is this growing, how much storage do I need to allocate, plan out based on trends and things like that. It's very difficult without running that describe every day and seeing how much free space I have left to do any type of planning, be proactive about storage. I don't want it to just go into a bad state because I ran out of space and then scrambled for disk drives. So is there any way to manage it in any way?
Right.
Because the frustration piece is so black box that it's almost impossible to be any type of administration.
Sure.
So we have a product called ArcGIS Monitor that can actually tie into the data store itself. And once it reaches a threshold that you set within that application, you'll get notified that, hey, you know, your data store is now at this capacity. What do you want to do with it? So that will kind of give you a guidance to how to kind of monitor your environment.
Okay, maybe this guy in blue here, then we'll come back to you, then you. Okay.
What about optimization? Tuning indexes, doing things to make the database be better.
So the question is how to optimize the ArcGIS data store, right? So on a daily basis, nightly basis, actually, we actually update the stats for the ArcGIS data store. So that's done. So at 10.7, we actually added sort of a query performance. So if you hit the same query multiple times, we'll add an index to that column so that it's quicker and quicker and quicker. So it is optimized for you. So the idea is we're always trying to be proactive and meet users' needs and get the best quality of performance or high performance as we can per release. And then, let's see, you and then you.
So, in the deployment, you say it's not recommended, but it's not vetoed to put the spatial temporal and relational into the same sheet, the same box? given file server restrictions, you need to. Other than a performance thing, you said there are any other gremlins that are likely to rear their head.
So if you're going to put everything on one box, we don't stop you. But what you want to do is make sure you have a very beefy machine with a lot of disk space. So the spatial temporal data store, really the sweet spot for memory is 64 gigabytes for it alone. So if you want to optimize 64 gigabytes for that alone, then add in additional memory for the other data store types. That makes sure you have a lot of disk space. And depending on your configuration and what you're doing, you can architect it accordingly. And then the gentleman in the black shirt.
So with the, what architectural considerations are there where if you need to ensure that you're continuously collecting the spatial temporal, that you need to have in place when you're doing upgrades or any other type of restore operations to make sure that you're not losing incoming data?
So if you want to make sure you have enough, you want to ensure that your backup policy is set to a frequency high enough that you capture that based on your organizational needs. So in other words, if you're getting, sensor data that's coming into your spatial temporal big data store, you can set you can set a backup that happens every single day by using the update backup schedule. So you would have to configure your backup location and set an automated schedule so that you can capture or you don't have too much of a lag in delta.
I guess really the core of what I was asking is, I'm assuming that the spatial temporal data store has to be put into essentially a read-only or even a shutdown mode when it's being upgraded from version to version.
Oh, I'm sorry, upgrade.
Window. What types of preparations would you need to have in order to ensure that you're continuing to collect information, whether to a fully parallel system or other components within it?
Gotcha. So the question is how to continually feed data in, but upgrade upgrade the backend spatial temporal big data store without losing any information, right? We don't have that architect currently. So what upgrade time means there's downtime.
Yeah. Lady.
Yes, ma'am.
Is there any plan to create some way of syncing features that are in your data store, feature services that are in your data store, back to something like SQL? Do you want that to be authoritative content?
So there have been discussions. It's not in the product plan currently, but there have been discussions, and actually one that happened earlier today, just before this meeting, about maybe having some methodology of doing that. So you want to sync your Oracle or in your the ArcGIS data store relational maybe, so that they're both parallel. Is that correct?
Right, not the whole thing, just the
certain ones.
services that we need back in our system of record SQL. But we want to take advantage of, like you said, the thousands of services that we can use the data store for, but only, and we still need them in other systems.
Yeah, so the current, yeah, I mean, so the implementation strategy that we have is that you use your SDE geodatabase for SDE geodatabase, and you publish by reference and point to it. And then for the ArcGIS data store, file geodatabase, GeoJSON, shapefiles, anything you need to persist into the portal interface, the enterprise application, use that for that. So it's sort of a two-tiered strategy, but I hear you, and I hear a lot of users asking for that. Yes, sir.
I inherited a system where we have the data store and everything already configured, they upgraded it, so it checks out. But the problem is, I'm getting that ARC set, ARC socks problem. I just dealt with it, and it seems like they're not going to let me test their whole. I don't know if this is what I just keep getting worse.
So you could get that problem if your publishers are publishing directly to server and not portal.
What was the problem?
Oh, sorry. So the question is, or the problem that he's noting is, he's seeing lots of socks spin up, even though the back end is the ArcGIS data store. So the one potential reason is if you publish directly to server and not through the portal interface, you could see that happen.
So if they're on ArcGIS, things in the URL are they're using published services.
Right, so they should, it's designed to use the enterprise app architecture going through portal. So through ArcMap, you can actually make a connection to your portal and publish that way, as opposed to, the way of going to like the 6443 URL or something like that. Yep.
So if I have all these ArcGIS on the server, can I migrate them to that?
So you can republish those services.
Okay, so you're going to have a lot more to do that. Okay.
Yep.
I have a question regarding the strategy. You just mentioned two data store new machines. So for example, if we have different operating system, I'm not talking about Linux and Windows, different Windows versions, will it still work or not?
Different Windows versions will work, yes. I need to start doing that. So the question was that can you migrate or can you use in the slide we showed a simple way of retiring one data store machine and then configuring another. Can you do that with different Windows versions? And the answer is yes. Now on Linux, you would probably have to do a backup and then restore on Linux. But it is platform independent from 10.5.1 onward. All right. I think that should be it.
All right, yeah, I think we'll just kind of wrap up, and then if you have additional questions, we'll be here for a little bit. Thanks, guys.
Thank you.